Welcome to Timber Talks, the podcast where we dive into the latest innovations and trends in the forestry industry. I'm your host, Mindy, and today we have a special guest, Greg Hay, Reforestation Advisor at ArborGen Incorporated. ArborGen is a leader in the development and supply of advanced genetic tree seedlings for reforestation. Greg, can you tell us about the historical evolution of reforestation practices and how ArborGen has contributed to these advancements?
Sure. Southern pine tree improvement started in the 1950s with the larger integrated forest products companies and collaboration with the universities to create tree improvement programs. And big improvements have been accomplished in both the productivity and the tree form. As tree farmers and timberland investors, our situation is pretty much like theirs in production and price following the agricultural experience in our country. And if we look at corn as an example, prices were largely unchanged for 35 to 40 years, even as the cost of production increased. Farmers stayed in business by increasing their production, and they increased that production through genetics, weed control, fertilization, irrigation, and in forestry, we call these treatments silviculture. When we look at the drivers of the productivity gains, we begin with natural regeneration, followed by planting, site preparation, fertilization, weed control, tree improvement, and finally clonal and biotechnology. ArborGen and its legacy companies like Union Camp, Champion, IP, Midwest Baco have engaged in a dynamic progression of forestry improvement through its continual orchard improvements, breeding, and selection processes, improving the productivity and saw timber potential of its products.
Okay. What current technologies and methods are being used by ArborGen to enhance tree growth and sustainability? Now, before you begin, I heard you say cloning. So could you explain to our listeners what you mean by that? Because some people may have a preconceived notion of what cloning a tree means.
Yes, we have replaced the word clone because it has a negative connotation to it with the word varietal. Again, we're following the agricultural industry, and varietal is a little bit easier on the ears. It is basically a varietal is a selected single best individual selected from controlled pollinated crosses. And I'll get into controlled pollination in a little bit, but it's taking an individual selected superior tree and mass producing that one tree so that you have millions of copies of one genetic genotype. And getting back to the current technologies that we use, we begin by making selections of individual trees based on the traits like growth and yield, disease resistance, stem form, wood quality, propagation efficiency, cold and drought tolerance. Then we initiate breeding of selected trees, followed by testing to determine the best families for commercial production. And there are three broad categories of genetics: open pollinated, where we know the superior mother tree, but we don't know who the father is. It's unknown. It could come from inside the orchard or outside the orchard. And that generally delivers about 20 to 50% saw timber potential at harvest. The next step up the genetics ladder is controlled pollinated, where we selected a superior mother and a superior father. We collect pollen from the superior father, bag the flowers on the superior mother tree, inject the pollen into those flowers, add the limb, and collect only cones from that limb where we've impregnated the flowers with the known father. The controlled pollinated materials delivering 60 to 80% saw timber potential. And then there are varietals, which I discussed earlier, single best genotype, and that's delivering 80% saw timber potential. With each of these three grades, open pollinated, controlled pollinated, and varietals, you're looking at a little bit increase in cost or that increased genetics and increase in superior saw timber potential. One important note, and I forgot to mention this earlier, there are no genetically modified trees out here. This is all through selection and vegetative propagation. So we aren't doing any GMO trees. We don't have any square trees yet with chocolate bark. None of that's going on.
Okay. Can you share some specific examples of how ArborGen's innovations have impacted reforestation efforts?
Sure. I'm going to start back in 1940 again with an agricultural example. when you look at corn families were available, you look at late 20s, early 30s, corn was producing yields of about 25 bushels to the acre. When hybridization of corn started, by the turn of the century, we had yields of in excess of 160 bushels to the acre. But to give you an example, back in 1940, the ag industry was at about a 20% adoption rate of hybrids. Today, we are at about a 20% adoption rate of controlled pollinated material. And one specific example of how adopting advanced genetics produced excellent results is that of an early adopter here in Prescott, Arkansas. He invested in a varietal loblolly pine and planted his stand in 2006 at a lower stocking rate and wider spacing. And by so doing, he yielded 24% chip and saw at age 15 when he thinned it. Put this in economic terms, pulpwood in that area was running around $7 a ton, but chip and saw $17 a ton. So quite a big difference in terms of the impact on his reforestation efforts using varietal pines.
Okay. Could you explain why? I mean, when I think planting a tree, I think, for production purposes, planting them close together, the idea of the more plants I have per acre, the more money I'm going to make. Could you explain why it's suggested to have more spacing now, where we would have fewer trees per acre, but yet you're going to make more money? That seems kind of counterintuitive to think of it that way. So
I understand. Good question. Good question, Mindy. Regards to the advanced genetics that we're using today, one thing that we've learned over the last 20 years with advanced genetics is you don't want to use conventional stocking rates. Because these trees grow so fast, if you plant them at conventional stocking rates, pretty heavy stocking, what happens is those trees begin to stagnate at a very early age. And right now here in Arkansas, we have a very difficult time moving pulpwood. Very difficult to get your stand thin because there's nobody willing to take the pulpwood. If you plant fewer trees to the acre, less can be more. If we take 10 acres as an example of open pollinated control, and we plant it at a pretty heavy stocking rate, 605 trees to the acre, our total cost for those trees run at about $968. Total revenue for that 10 acres is going to be about $25,670. If we take that same 10 acres and we employ advanced genetics at fewer trees to the acre, instead of 605, we drop down to 454 trees to the acre. Then a little higher cost, $1,251, an additional cost of about $283. But that additional cost is going to generate a total revenue of $36,000 compared to $25,000 for the higher stocking rate. So you've got an increased revenue of $10,000 on 10 acres. And for every dollar that you've invested in those advanced genetics, you're getting a $37 return. Widening your spacing and planting fewer trees to the acre and moving from perhaps a two-thin regime silviculturally to a one-thin regime and harvesting earlier, you with spacing out those trees, and even with that one-thin regime, maybe taking out 50% of the trees, taking out every other row, you provide some incentive for a logger to come in and log your tract as opposed to thinning at every fifth row or every third row. And by widening your trees in your rows and planting fewer trees to the acre, you not only get a better quality of product, you're moving up from pulpwood into chip and saw or small saw timber. And that's the advantage. Even though you're planting fewer trees to the acre, you're elevating your product grade out of pulpwood into chip and saw, a higher value product. And that's where you're getting more money for that higher value product and netting a higher return. And in addition to that, when you thin out those trees and you're going to a wider spacing, you're improving your wildlife habitat. You're getting more sunlight on a forest floor, giving you more forbs and legumes for your wildlife species.
Okay. Right.
So it has other benefits just besides timber.
Right. Well, I mean, habits die hard. And, a lot of people think the more, the better type of thing. But we've kind of learned those hard lessons in ag in some ways.
Yeah.
So, what upcoming technological advancements do you foresee in the forestry industry, particularly in reforestation?
That's another good question. I see a move in reforestation activities. We've moved into intensive forest management activities in the past, where we're doing a much better job of intensely managing the land for forest production. But as we move forward, I see a move from intensive forestry to precision forestry, just like ag, where ag is controlling the amount of herbicide and the degree of planting across a tract of land, across a field, depending on the soil types. I see that kind of precision moving into forestry as well. So it's very challenging to foresee its application in the future when it comes to advancing technology, but perhaps artificial intelligence and robotics can be employed to improve efficiency and reduce the cost of vegetative propagation, for instance. Additional advances in mechanical engineering to develop new machine planting equipment. I see that moving forward with the cost of labor being very, very high. I see more and more mechanical planting being done each year, and that provides greater uniformity and consistency of how those trees are planted. The use of molecular marker genomics for enhanced disease resistance screening beyond the fusiform rust and pitch canker that we currently screen for. Continued adoption and adaptation, perhaps, of drone technology to evaluate seedling survival and their use in precision fertilization, insecticide and herbicide applications. A true transition from intensive forestry to precision forestry is going to take time, but I see it moving forward.
Do you see, we have like robotic lawnmowers now. Do you foresee a technology like that as far as instead of a person going in and manually mowing around the trees? Do you see that being a possibility?
Well, we don't see a lot of mowing around the trees on an operational scale with the acreage that we're talking about. Most of the silvicultural treatments are done on a much broader scale. So individual tree treatments, few and far between. You might see some of that going on at hardwood stands where you're really limited as to what you can use over the top of freshly planted hardwoods. But I don't see that happening operationally in forestry at this time. We have seen an introduction of geo-referenced tree planting where they're putting GPS equipment on the dibble bars so that each tree is geo-referenced. And if you're going to wider spacing for interplanting, planting holes in that, I could see that happen and maybe increasing in its use operationally.
Okay. Well, I could see the geolocation technology you were talking about, sending robots out where they, for precision farming, where they could apply the herbicide or fertilizer or whatever, because they would, it would be electronic boots on the ground, so to speak, versus a person going out there and doing it, using the precision farming technology that we have now. How is ArborGen preparing for future challenges and opportunities in the industry?
I guess first and foremost, we're continuing the introduction of new genetic families, offering improved yields, wood quality, and drought tolerance, and improved saw timber potential for the families that we're creating, increasing the production of the containerized stock to meet the demand for earlier planting and wider planting window. Containerized stock allows you to go out and plant earlier in the year and plant later in the year. And it also allows you to plant some tough sites with a tree that's already got soil and root encapsulation in that plug. So that's something that we're increasing. And in addition to that, we're increasing our hardwood production to meet the increasing demand from the carbon market.
So how many tree species are you all currently working with?
How many tree species?
Yes. Or families, whichever.
Yeah. Well, the species, principally loblolly / longleaf. We do have some pitch pine, and some shortleaf pine, and just a little bit of Virginia pine. Predominantly, it's loblolly.
Okay. All right. The reason I asked, I had another client that was talking about how they are foreseeing a higher demand for wood because of some new technology. They're using nanotechnology to sort of like separate the fibers of wood. They're actually making nails out of wood, which is, I thought that was really, which is increasing the demand. And they're trying to get away from concrete and steel as far as structures for buildings and go back to wood. So I was just curious as to how broad a range you all carried.
mass timber production is increasing in terms of the use of mass timber for building, whether using glulam or laminated beams for building, or we're doing that here in Arkansas. Other states are also utilizing that, and we see an increase. I think it's slowly being adapted to. Folks have been using the conventional building materials like concrete and steel for a long time. Moving forward with wood, it takes a paradigm shift for these contractors to move forward in that regard.
Right. I was just curious because, there's many demands for land, whether it's ag, forestry, urban development, and with a higher demand for wood now, exactly how that was going to affect you all. If you thought you might be branching out to some other species, perhaps, to try to meet the demand.
The other species that we're involved with is the hardwoods, and those are principally oaks, a variety of oak species. Currently, we're only growing 5 non-oak species. We had to make room in our nurseries for oak production because the oaks are sequestering more carbon than other soft-seeded hardwoods. Mm-hmm. So we had to make room for more oak production to satisfy the needs of the carbon companies, and their demand is really growing exponentially in the last few years.
What advice would you give to professionals looking to stay ahead in the rapidly evolving field of forestry?
I guess first and foremost, I would advise young professionals to get engaged in their professional associations, whether that be the Society of American Foresters, Association of Consulting Foresters, as well as their state forestry associations, to stay abreast of recent technology, advances in applied silviculture, and networking within the profession. It's real important to network within your profession. And foresters, we tend to be pretty isolated in our profession, and many of us are introverts in our personal nature. We're not very outgoing. We're not very involved in other activities, and to stay abreast of the new technology and the evolving field of forestry, it's really critical to get involved with your professional forestry associations, your state forestry associations, as well as any national organizations like the Society of American Foresters, Association of Consulting Foresters. There's Forest Landowners Association as well. That's important if you own land, to be involved in those, to be engaged in national legislation protecting private property rights and what you can and cannot do on your land.
Okay. What are some common challenges faced in reforestation, and how can they be addressed efficiently?
Some of the common challenges that are faced in reforestation that I run into when dealing with private landowners. One is the inadequate or simply no site preparation. And it's imperative that you properly prepare the site just as you would a garden prior to planting, so that your options are much greater before planting to site prepare a tract than after you plant. Poor planting quality resulting in poor survival is another challenge. It's critical to be on the site when the trees are being planted. If you contract out your planting to a tree planter and you're not out there when it's being planted, you're not going to get the quality of tree planting you would if you had somebody out there inspecting the tree planting while it's being performed. I think the third biggest challenge that I see out here in dealing with private landowners is that they tend to believe that if you're planting these trees and you're doing a good job of site preparation, you don't need to control the weeds and grasses. You don't need to do any herbaceous weed control. And that treatment is essential to optimize your survival and your growth, to give those trees all the water and nutrients that they can have at stand establishment. You got to remember, we've got one chance to get this right. What we do at stand establishment, we're going to have to live with for the next 25 years. I often use the analogy of Maximus in the movie Gladiator, where he stands in front of his troops on a horse and he says, what we do in life echoes in eternity. Well, what we do at stand establishment, we're going to have to live with for 25 years. So it's really important to get it right.
Do you all offer, for the private landowners, do you all offer any type of classes that teach the landowners exactly what to do so they can achieve the most success possible?
We do through webinars and a lot of tools that are available on our website. You can use a tool called a revenue calculator that will compare one family of trees against another family of trees, perhaps at different stocking levels, to give you an idea of what your increased revenue might be. When I deal with landowners, I typically run into three concerns. One, they're overwhelmed by the planting process. It's the first time they've ever done planting. They're not sure what to do. Secondly, they're confused by all the genetic options available, not sure which to select based on what they want and what they can afford. And three, they're skeptical of investing in advanced genetics given the poor returns we're seeing in the timber market today. And the best way to address these concerns is to find a consulting forester that you trust and are comfortable working with it. I'm a consulting forester and serving as a Reforestation Advisor with ArborGen. I have to work with landowners. When I consult with landowners, I help them to find what their reforestation goals are and advise them of the genetic choices and families that are best suited to their land to achieve their goals. And this often involves guiding them through the entire reforestation process, including site preparation, choice of genetics, stock type selection, spacing and stocking rates, planting methods, herbaceous weed control, and available vendors to accomplish this work. But I encourage landowners, first and foremost, to get involved with a consulting forester that they trust and are a good fit with.
Okay. You mentioned Arkansas. Is ArborGen branching out to more of the global market, or is it just particular in Arkansas?
That's a real good question. We've got 7 nurseries throughout the southeastern United States, which is where we predominantly serve, but we've also got operations in Brazil. Funnel and biotechnology is very prominent. South America is nearly at 100% use of varietals. And down there, the varietal production is a lot less costlier than it is here in the U.S. because labor costs are so much lower down there. But all the eucalyptus stands down there, they're all varietals. They're about 30 years in front of us in terms of the adoption of varietal technology in forestry.
Can you share best practices for selecting and planting genetically advanced seedlings?
Yeah, I would say that I can do that. Very good question. I deal with that a lot in my presentations. First and foremost, dealing with a lot of private landowners, you have to help them define what their objective is, what the specific product that they want to use is, where their market is. What are they growing these trees for? Why? Why are they reforesting? And many of them give me a blank stare when I ask that question. What is the market? Where's the nearest sawmill? Is it a pulpwood mill nearby or is it a sawmill nearby? I want to find out the specific product they're interested in, where their markets are at, what kind of return on investment that they're expecting. And then we select a species and a family that's native to their area. And here in Arkansas, I want to use a species that's native to Arkansas and a seed source that's from Arkansas. Selecting the genetic category and grade to meet their objective and their budget is really important. When you move up into controlled pollinated material, you're going to get a much greater return on your investment. You're going to get a higher grade of product, but that's also going to cost a little bit more to get that advanced genetics. And you want to look at something that's suitable to your soil type, minimum average temperature, and your forest management objectives. You want to request, I ask landowners all the time, request the performance data for the family you select. Performance data is available for every family out there today. The families are rated individually in their performance in terms of productivity, in terms of disease resistance, in terms of forking, straightness. All of those come into play when we're looking at individual characteristics and performance traits for each family. And today that information is available, whether it's in the East with the performance rating system developed by North Carolina State University, or over here in the West by the Western Gulf Forestry Improvement Product Group out of Texas A&M. So that information is available just for the asking. And it's real important to have that information going forward to staple it to your track map. And future, I've already had appraisers ask me, Greg, can you tell me what family was planted out here? I might be able to provide a greater appraisal of that land, knowing that better seedlings were applied out there, genetically advanced seedlings were applied. And one thing that we've learned, again, over the last 20 years, you don't want to plant these advanced genetics at conventional spacing and stocking rates. Choose a wider spacing and a lower stocking rate to achieve higher value products. There's two avenues of thought when you get into stocking rates. Plant them thin, you'll likely win. Plant them thick, thin them quick. I encourage people to look at advanced genetics, planting them at a wider spacing and a lower stocking rate. And be sure to be on site when that planting is performed. Those are some of the practices I generally advise landowners to perform.
And why is it important for a landowner to plant native species versus, some other species that they've heard will give them a larger return, but it's not native?
Because the provenance where those seedlings are selected from, the mother and the father that produce that family, they're going to be more adapted to the climate of that specific region, the cold tolerance level, the average minimum temperature of that area. If you plant Florida stock in Virginia, it's not going to perform well. If you plant South Carolina stock in Arkansas that's not been tested, when we have 14 inches of snow or a hard cold snap, we're going to see that those South Carolina trees are not as cold tolerant as Arkansas or Texas trees are. And they're not going to be as drought tolerant as perhaps Arkansas or Texas trees will be.
How can forestry professionals ensure they are utilizing the latest tools and techniques to maximize reforestation success?
First and foremost, use the advanced genetics that are available today with controlled pollinated material. Utilize ArborGen's revenue calculator to compare increased revenue with the genetic options and different stocking rates. Consider planting fewer trees and a wider spacing to create more options for solid wood and higher value products. Request the performance data on the family that you selected and record the label on the box or bag of seedlings. You can do that with your camera on your phone. You're going to see a label on every bag. Take a photograph of that label so that you know what you planted out there. So if there are problems in the future where you particularly like that species and how it performed, you like the needle nest, you like the color of those trees, you like how fast they grew, you can go back and look at that photograph and look at that label and say, I want this family again.
Or they could go back and talk to you guys and see what they purchased.
Exactly.
Well, thank you, Greg, for sharing your insights and expertise with us today. It's been a fascinating discussion on the advancements and future of reforestation. To our learners, make sure to follow or subscribe to Timber Talks for more episodes on forestry innovation. Until next time, I'm Mindy, and this has been Timber Talks.